Hello everyone. In this series of GUJCET, today we are going to solve paper of 2018. Here is a question of determinant with factorial terms. So we'll try to reduce the factorial. From the first row, we have 10 factorial as the least value. So we'll take 10 factorial common. From the second, we have 11 factorial. And from the third, we have 12 factorial. So our determinant will be, first row we have taken 10 factorial common, so 1 will remain here. This will be 11 into 10 factorial, so we will have 11. This will be 12 into 11 into 10 factorial, so we have 12 into 11 over here. Following the same pattern, we have 1, 12, 13 into 12. 1, 13, 14 into 12, 14 into 13. Okay, now we want to reduce this so that simplification can be easy. We will apply R3 changes to R3 minus R2. So this is 10 factorial, 11 factorial, 12 factorial. So this is 1 minus 1, 0, 13 minus 12, 1. And then from 14 into 13 minus, so we are actually having like this, 14 into 13 minus 13 into 12. So we take 13 common and we have 14 minus 12. So it is 13 into 2. The same thing we will do with the second row. We'll subtract or apply the operation R2 minus R1. After the operation is completed, we have this determinant. Now we will simplify this along the first column. So expanding along column 1, we have 1 into 1, 12 into 2, and 1, 13 into 2. So that is 26 minus 24. So we are left with 2 into 10 factorial into 11 factorial into 12 factorial. That marks the B option. Okay, here we have S is equal to P plus Q plus R, and we want to find the value of this determinant. If we observe row wise, we have S plus R plus P plus Q everywhere. So we are going to apply R1 changes to R1 plus R2 plus we see that in the first row, if we add these columns here, we get the same term as the second and as the third. So we are going to apply C1 changes to C1 plus C2 plus C3. So that makes this S plus R plus P plus Q. Same for the second row first column entry, and same for the third row first column entry. Remaining will be. So we have S plus R plus P plus Q common. That leaves us with 1, 1 and 1 in the first column. P plus Q plus R is S. So this becomes S and it is S plus S to S. Let's make this 0 by applying R2 changes to R2 minus R1 and R3 changes to R3 minus R1. And that's what we get after applying these operations. Now expanding along the first column, we have 1 into S, that is S square, and so it is 2S cube. Option B, that is. Here we are looking for a matrix B which is satisfying the condition AB is equal to BA. So we need to go option wise. Let's take the first option. Multiplying matrix A and B, first row first column, X plus Y, first row second column, Y, second row first column, Y, and second row second column is also Y. Now let's find BA. So here AB is not equal to BA. So we have to go to the second option and check. So when we check with the second option, we find that AB is equal to BA and the condition is satisfied. So that's option B now. If it would not be option B, we would have to check with option C. And if not, then D would be the answer. This is a very simple question. We have to find A cube. So first we'll find A square, which is A into A. So we'll multiply the same matrix with itself. So using matrix multiplication, we have first row into the first column. So that will make 3 into 3, 9 plus 9 plus 9. That is 27. So each of the term here will be 27. And then to find A cube, we will take A square into A. So now we'll multiply A square with this. And that will give us 27 into 3, 3 times. 27 into 3, 3 times. That is actually 27 into 9. Each and every term will be like this. That is 243. If we need this to be equal to A as per the option, we have to take 81 common. So that every term will become 3, and that is matrix A. So the option is 81A. then because we have x raised to 4 plus y raised to 4 plus z raised to 4 is 0, that means that each and every term should be 0. Only then the sum of their positive exponent, it's raised to 4, even exponent, so only then will it be 0. That's why we are going to take x0, y0, z0 in this determinant. On putting x, y, z0 and expanding, we have 1. So these were matrices and determinant question from 2018 paper. In the next video, I'll be taking up calculus of the same paper.